Hello and welcome to today's webinar, Network Transformation. This is the first part in Esri's 2019 Telecommunications webinar series. My name is Randy France and I'm Telecommunications Industry Strategy Lead for Esri. Also joining me today from Esri is Patrick Hulls, Solution Engineer Team Lead, and Tyler Pilarczyk, Solution Engineer. As I said, today's webinar is the first in a four-part telecommunications webinar series. Our next webinar on customer experience will be held on May 15th. Next, in the fall, revenue growth will be covered on September 11th, and we'll be closing out the series in November on 13th, resource optimization. All webinars are recorded and the links will be shared. All times for the webinars will be 1 p.m. Eastern Time, 10 a.m. Pacific Time. A little bit about the logistics. There's an orange box with a white arrow in it. You can expand or collapse your control panel. We suggest that you adjust your view to full screen. That will give you a better view of the presentation as well as the demos which we'll be showing. We will have a Q&A session at the end, but we encourage you as we're going through the presentation, don't wait for the end. Submit your questions as you think of them, as we're going through the presentation. Don't forget to hit the send button. We'll be collecting those questions and then we'll be answering them at the end. And as I said, the webinar is being recorded, which will give you an opportunity to share it with your colleagues in the future or perhaps review a section that you find particularly interesting. As far as the agenda today, we'll be talking first about current trends and network transformation. What's it all about? Why is it important? And why is it that you need GIS and spatial infrastructure to support it? And what is GIS and geospatial infrastructure? We'll be covering that in detail. Then we'll be looking at ArcGIS in action. ArcGIS is a GIS platform that Esri has built over the years, and we'll show you specific applications of how ArcGIS platform can support the network transformation. Then we'll go through the Q&A. So what are some of the trends and drivers in the industry? And I'm sure everyone's seen these before. I mean, this is really in a package digital transformation. We're rebuilding the entire industry. And why are we doing this? Well, first off, resource optimization. We need to reduce costs in the industry. And those costs are not just the expense dollars, but also the assets. There's a limited amount of capital, and there is a need to provide new products and new services. So you need to optimize those investments. And we must also grow the revenue. The additional revenue is going to give the money that's necessary for more investments as we rebuild the network as well. And this helps in both the deployment of the assets, but also some tools that are available for marketing and sales to monetize the assets that have been built. Customer experience. Customers aren't happy in a competitive market, you lose market share. You can't grow the revenue if you don't have those customers. So we'll be looking at different ways to improve customer engagement and experience. And all of these center on network transformation. Without transforming the network and making it better and more efficient, you aren't going to grow the revenue, you aren't going to improve customer service. And another thing companies are looking for today is digital services, new products, new services out there. Once again, networks must be transformed to make this happen. And you must put the right technology in the right place at the right time to meet customer needs. So what is network transformation then? And what are the steps involved in executing it? There's three basic steps that we look at when we talk about network transformation. The first is the strategic planning. Plan out the network, that makes sense. The next thing, design the network and build it. And then the last part sometimes gets shortchanged is the operational awareness to track where you built it. So let's talk first about strategic planning. We like to put GIS into three phases we call descriptive, predictive, and prescriptive. The first one is descriptive. That's essentially saying, well, you've seen it before, maps. You can create maps, describe what's out there. Where's your plant? Where are the customers? Where are problems? Things like that. But if you're going to do strategic planning, you need to collect all that information. You need to know where the network is. You need to know where the demand is, where the customers are. But to plan, you need to predict. So predictive is using tools that are available in a GIS to be able to predict not just what is happening today, see what's happening in descriptive, but predict what is going to happen in the future. That's strategic planning. Understand the market, where it's going, and what needs to be done. What kind of capabilities and technologies are necessary to meet the demands, not just today, but in the future. And today's network and services, telecommunication services, are more complex than ever. There's no longer just, when I came in the industry, copper plant. Now you've got fiber, you've got HFC plants, you've got wireless, all kinds of technologies which are great to provide the services, but which one to use? You need to be able to predict what the customers want and what the revenue opportunities are. And then you need to execute. That's where prescriptive come in. You need tools to help you design the network, decide what specific technology goes where that's going to give you the optimal results, that's going to maximize your return on investment. That's what remote engineering is all about. Too often, companies, though, sort of stop there. They miss the last phase, which is operational awareness. What is operational awareness? Well, if you build a network, you can't just say, well, they will come. You need to market it. You need to sell. You need to monetize that investment, and you need to have the operational team ready to do the installation, ready to support the new customers as they come on board. We have worked with companies that have not implemented GIS, and what we have learned is, in many cases, they built a network, they made the investment, but they haven't monetized it because marketing, sales, and operations don't know where it is, what those new services are. If you don't market and sell them, you're not going to monetize that network. So that's the three phases there: the planning, the engineering, and then the operational awareness. So where are you today in your implementation, your network transformation? What we've got is we've got an audience poll here, and we'd like to know what type of technology are you deploying to support your network transformation, and select all that apply. Are you looking at 4G, 5G, maybe cell densification? Perhaps you're looking at a deeper fiber deployment, get that bandwidth deeper into the edge. Or HFC, hybrid fiber coax. A lot of companies are also deploying Wi-Fi, or software-defined networks, or network function virtualization. So we'll give a few moments here, select all that apply. See a few more comments coming in, and then we'll see where everyone's going. Okay. About another 5 or 10 seconds here. Some good responses coming in. Okay. So let's see where we are here. Well, it's interesting. Deep fiber, I could see that. Everyone is deploying fiber. So we got 76% of the respondents of our audience here is deploying fiber. Close behind it is cell densification, 4G and 5G. Those are the hot topics. So those are the areas where, you would expect to see, or need solutions that are going to help you in those areas. So next, what I'd like to do is, okay, we see where everyone's going. So what type of GIS or maps are you using? And once again, select all that apply. Where are you using GIS and maps today? Is it in that first phase, strategic planning? Or perhaps in the prescriptive phase where you're actually designing the network? Or how about that last phase we talked about, operational awareness? Or perhaps you're not really using maps or using GIS in any of those. A few more minutes for the responses to come in, and we'll see where everyone stands on this. Wow, we're getting a lot of good responses here. Okay, about another 5 seconds. We'll let people make their selection. like we've got everybody in, and let's share those results. You know, this is interesting. This is sort of what I would expect. We see a lot of people using, or a lot of our attendees using GIS and maps for the strategic planning component. We see about 50% are remote engineering. I'm surprised at the operational awareness. I'm glad to see it's that high, that 49%. And then we've got 10% that are not using any of them. So this should be a good opportunity, a good webinar for you to be able to see some of the solutions that we have really made available to our customers here. So what I'd like to do now is I'll turn it over to Patrick and Tyler here. And Patrick will be talking about the science of where and geospatial infrastructure. And Patrick, why don't you show us how we can leverage this for the whole network transformation process?
Great, thank you, Randy. So as GIS has evolved within telecommunications, more and more organizations are applying what we call the science of where within their business. Now, the science of where is a framework and a process for measuring, analyzing, understanding, and collaborating using the power of geography. Now, GIS was once thought of only supporting data management or mapping, like managing facilities or as-built or mapping customer locations. But in order to support network transformation, GIS is being used for analysis and modeling to be more strategic in where new networks are deployed. GIS is also starting to be used in the planning and design phases, as well as allowing organizations to take action in the decision-making process for new network projects. And in order to support all of these new applications of GIS, new geospatial infrastructure has emerged. So, what is this geospatial infrastructure? Well, it supports geographic data and content management through a system of record, and not just in a siloed environment, but the infrastructure should leverage the web services and open APIs in a system of engagement for easier access and integrations to that system of record. Geospatial infrastructure also supports traditional mapping and analytics in 2D, but also in 3D, in real time, and with big data through a system of insight. And all of this infrastructure should work together, creating a platform for sharing and collaboration. Esri's ArcGIS is a complete GIS for telecommunications because it empowers all aspects of an organization with geospatial infrastructure. ArcGIS offers a GIS system of record, system of engagement, and system of insight that all leverage the power of location to enable network transformation within your business. So let's go ahead and see how ArcGIS and a complete GIS can support network transformation. And first, we'll start with the strategic planning and Esri's strategic planning tools, which allow for spatial analytics to be performed on millions of data points, and then the results easily shared into reporting or BI dashboards. Here we have access points spanning the entire US. Each of these wireless access points has been collecting a series of subscriber transactions over a period of months. This allows us to see per access point or tower all the subscriber information. But just looking at this map and all of these access points, it's really hard to see any trends in subscriber behavior. So using Esri's strategic planning tools, we can take all of these points and spatially aggregate them to hexagon bins. This allows us to get more of a subscriber behavior map across the entire US. Now, these tools can be run directly within an ArcGIS app like this, or they can be run directly with a big data environment like a Hadoop cluster. Now, each of these hexagon bins contains summary statistics of all the access points or CDRs within that particular area. And as we pan and zoom in on the map, we'll notice that the size of the hexagon bins start to gradually get smaller the closer into the map that we go. This allows us to see greater detail the closer we get. Now, this spatial aggregation not only can be performed on 2D data, but also 3D data like CDRs that contain a Z or a elevation value. So here we have a building in which we've recorded those CDRs within the building. We've symbolized all of these CDRs based off of the coverage quality at that particular location. Now, what we can do is take these CDRs and aggregate them floor by floor within the building. This allows us to start to see where our subscribers are using devices within the building and gives our network planners a better idea of the coverage quality floor by floor. Esri's strategic planning tools also allow you to take that CDR data and snap it to other geographic features. For example, we could snap it to buildings, so we could see potentially the total download or consumption of data within a building footprint. We could also snap that data to street segments and maybe symbolize it based off of latency for autonomous vehicle planning, seeing where we might have poor latency on the streets. And finally, all of the results of these strategic planning tools can be easily shared up into the ArcGIS system of engagement so that these records can be consumed by a configurable ArcGIS application. One of those applications may be a dashboard app that creates a report of the results of those strategic planning tools. So within this dashboard, we have summaries across the top and the side that show us the total download, upload, the average coverage quality, the total failed connections, average speeds, and average latency of mobile transactions and devices across our entire wireless footprint. And as we pan and zoom in on the map, we'll notice that the summaries are dynamically changing based off of the map extent. Now, we also have some preset filters on the left-hand side. So if I wanted to see these summaries for iOS devices versus Android devices, I could compare those two. If I also wanted to see transactions that had a higher coverage quality, we can start to filter that in. And maybe we also want to see those same transactions that have poor latency. So having the ability to filter this content based off of these preset filters, as well as the map extent, allows our organization and management teams to see exactly where we should be having these network transformation projects. So Esri's strategic planning tools allow for organizations to spatially analyze data like never before. This brings out new insights that allow network planners and management teams to better understand where in their network transformation should occur. So let's move on to remote engineering and Esri's desktop and walkout surveys solution, which can aid engineers in performing 3D and fiber routing analysis, as well as gives them access to geographic content to make smarter decisions, while enabling engineers to perform their walkout surveys. So as a network planner, I've been tasked to help meet some of our network transformation goals, including deploying some new fixed wireless 5G locations. So using our desktop and walkout survey solution, we can use the exploratory analysis tool to start to look at where we have true line of sight from existing poles or locations that we can attach our 5G equipment to. So first, we'll load from our layer that contains all the potential wireless locations within the city that we could deploy our 5G equipment on. We'll also change some of the properties of our wireless sites and then run the analysis. Now, what is returned is a line of sight map. The areas in green are true line of sight to different buildings based off of our 3 tower locations or potential tower locations. The areas in pink do not have line of sight, And then the areas in yellow have overlapping coverage. So if we zoom in to our target building that we want to serve with fixed wireless service, we can see that from this particular location, we would be able to put an antenna on this side of the building and be able to serve it. And if we zoom around to the back side, we'll notice that this location on the side of a parking garage could also serve this building with true line of sight. Now I know that this location here is closer to an access point on our fiber network. So what we want to do now is figure out how to feed that particular wireless access point with fiber. Now, before we go ahead and start to figure out our plan of how to serve that location with fiber, we want to make sure that we are tracking our build-out project from the initial design all the way through construction. So using ArcGIS, we are able to integrate into a project management system and pull that information into ArcGIS so we can visualize it, as well as update the status of these projects directly from within ArcGIS. So on the map, you'll notice a blue project boundary that represents a new project. We also have our wireless access point that we need to serve with fiber, but we also have 4 other business locations that we need to deliver fiber to as well. So using the desktop and walkout surveys tool, what I want to do first is update the status of this project to initial design so we can start planning our fiber routes. Now, I could start planning our fiber routes by hand and seeing how these routes could start to connect up, but using our desktop and walkout survey solution, we can leverage a backhaul tool that allows us to optimize those routes based off of certain design criteria. So using this tool or this model here, there are 2 main pieces or elements. The first asks us to locate our build-out locations as well as our network access points, which in this case, if we go back to our map, is this vault location up in the upper right-hand corner. The other part of this first step is to configure our design rules. Do we want to avoid costly routes? Do we want to do aerial or underground build? We can optimize the route based off of that input criteria. And then the second part of this tool actually does the routing analysis and connects those fiber routes up together, and then takes the results of that and adds it to our walkout survey. So to be able to run this analysis on these 5 sites takes a few seconds to run, and the results are shown here in red. Now, because we are tapping into that project management system with ArcGIS, we can tie all of these initial design elements directly to this project. So anyone can go in, click on a project, and start to see the associated initial design and those design elements, including all the fiber routes that were generated by our backhaul model. Now, the last thing that I want to point out within our desktop tool is the ability to leverage additional geographic content. This may be base maps like aerial imagery or high quality aerial photos that were recently collected, as well as tapping into Esri's spatial library of geographic content that we curate and manage and provide through ArcGIS. So if I wanted to add a corrosive soils layer into our map to help us plan better routes, we could easily add that into this view. Now, since we're using ArcGIS and leveraging that system of engagement, these initial plans are instantly available to our field engineers to be able to go out and perform their walkout survey. So what I want to do now is turn it over to Tyler, who will be our field engineer performing his walkout survey. Tyler?
Great, thank you, Patrick. I now want to use an ArcGIS mobile app from the field to confirm whether the routes Patrick just generated for us are actually serviceable. So the map I'm using is fairly similar to the one we were working with from the office. I can see my project boundary, the different fiber routes, and access points we need to serve. And on the left-hand side, I can also see other information related to the project, including the job status, which is telling me that it's ready for the walkout survey. Now, as I'm conducting the survey, I need to be able to provide updates to this map to notify our office engineers what changes need to be made to the proposed routes. But the first thing I'll do is go into my job assignment and change the status to walkout. That way the rest of my team knows that I'm performing the walkout survey. Next, I'll zoom into where I'm located in the field, and I've noticed that this route going east doesn't have enough poles to support the aerial fiber cable we're proposing here. So what I want to do now is use our editor tool to apply a markup to this map that indicates just that. I'll go ahead and provide a map label here. And then apply some or include some comments. And since I'm on site, it makes sense for me to take a picture of what I'm seeing. That way those in the office can experience what I am out here in the field. So in this case, I'll take a picture of our Esri globe. Once I'm done with the markup, I'll go ahead and submit this. Great, so the next thing I want to do now is propose a new route based on the observations I've made here. So if I zoom down, I've realized that this street right below the school, Jackson Street, and up Rosalind Avenue all have poles with sufficient room to be able to support our aerial fiber cables. So this time I'm going to use our editor tool to mark a line map note to show where I would propose that new route. I'll give this one a new label too. And submit my changes. So by using a mobile ArcGIS application, I was able to instantly access the fiber routes that were generated by our engineers in the office and include the changes that needed to be made based on what I saw in the field. Patrick, back to you.
Great, thanks, Tyler. So back in the office through the desktop application, since we are leveraging that system of engagement, that update information is instantly available to me as our desktop engineer. So we can zoom in and start to pull up that information that Tyler just collected from the field, including any attribute information or comments about changes to this particular route and any images that were collected. So the last thing that I want to be able to do is now update the status of our project. So we've gone through our initial design phase, we've gone through our walkout phase, and what we want to do is update the status of this to final design and send this off to our designers to do the final engineering. This data can be instantly integrated with an engineering tool, a CAD-based solution, or another GIS-based solution to push this data into it. So as we just saw, Esri's desktop and walkout survey solution allows engineers to perform remote engineering through quick desktop survey tools and offers mobile apps for walkout data collection. Now, with all the network transformation projects occurring in your organization, it's important to have better operational awareness. Esri's project tracking and monitoring and field inspections and surveys solutions allow management teams to stay on top of projects by understanding where projects are occurring and enabling field techs to collect information and update their management teams throughout the construction process. So here we have a dashboard that allows those management teams to stay on top of all the projects going on, so we don't do designs on top of each other. It also allows us to stay on time and on budget. So in the upper left-hand corner, we can see the total number of projects that are occurring, as well as all of the project statuses. We can also see the type of projects that are occurring. And each of our projects on the map are symbolized based off of their current status. And if we go over to the right-hand side and look at our job list, and we select on our most recent job or project, we zoom right to the location of that and can pull up all the information coming from our project management system. And as we can see, the current status of this particular job is construction under review. So what this tells me is that the project has gone through that final design and construction has started, and construction has also completed, and our contractors have let us know that construction has completed. So now we need to send our field tech, Tyler, back out into the field to take a look at construction and verify that it has indeed been completed. So I'll turn it back over to Tyler to perform our verification survey.
Great. So as someone tasked with determining whether a project has been fully completed or not, I need to be able to quickly see which projects are ready to be finalized and complete the verification from the field. To do that, I'm going to open a map in our Explorer app that allows me to see all those active projects symbolized according to their status. So in this case, I'm going to go over to Orlando and view the project we were working on. Once I open its pop-up, I can view the information related to the project and select the complete field verification link when I'm ready. That then sends me to a survey form that's been specifically configured for me to record the necessary information for the verification. You'll notice in the project info category that the form was aware of the project I was viewing in the previous map and automatically inputted its ID for me. And as I go to the other sections, I can easily begin to answer questions on if we have telecommunications to the site, whether there's power to the site, and if there's any evidence of construction, whether there's leftover equipment or staff that's still working on site. Once I'm ready to approve the project, I can select yes for my verification completed question. It's worth noting, though, that we've included some logic within our survey to adapt based on how I answer certain questions. So let's say the project hasn't been completed yet and I'm not able to complete the verification. I can select this as no, and the survey will know to prompt me to include other information specifying the work that needs to be done to complete the verification. In our case, the project went well. I can select yes, and then submit that survey back to the office. And once sent, those in the office will realize and understand that this project is ready to be finalized. This time around, I used a couple ArcGIS mobile apps to see which active projects were ready to be verified and used a smart survey form to complete that verification from the field. Patrick?
Great, thanks, Tyler. So our project has gone from the strategic planning through the initial design phases, through the build out, and is now complete. We've let our management teams know, and now we need to tell sales and marketing that they can start selling services based off of the construction and the design that just went through the entire process. So with Esri's solutions for enhancing operational awareness, we saw how management teams can easily track projects and how field techs can update their managers in real time from the field. Now, ArcGIS, as I mentioned, is a complete GIS for telecommunications that offers these focused business solutions for network transformation on top of industry-leading geospatial infrastructure. With ArcGIS, your organization will be able to meet all of your network transformation goals. So what I'd like to do now is turn it back over to Randy to open it up for questions, and we can start answering some of those. Randy?
Thank you, Patrick. Thank you, Tyler. That's amazing. All the different tools that are there that walk you through the entire process is incredible. As complex as the network is and the market is nowadays, tools like this are just essential to keep on track and to really optimize that investment. So super. We've got a lot of questions here, so let me get to them. One of the one I've got repeatedly here is, will we get a recording? And yes, absolutely. The recording will be made available. A video will be published. We'll be sending out the link to all attendees within the next week. So you should get that directly. Just look for the link in the email that we send to you, and you can look at it, peruse it, share it with your colleagues or whatever necessary. Some of the questions we have here. What are the mobile apps that were shown?
Randy, I can take that one.
Okay, Tyler.
Sure. So in the first mobile demo, I used Collector for ArcGIS, which is our map-centric application. So that's really designed to be able to make edits and updates to your map, whether that's creating markups or new features like I did, or editing existing features already available in the map. And then in the second mobile demo, I started an Explorer, which is an app that's tailored so you can immediately access the maps that your organization has made available to you. So that's how I brought in that map of active projects. And then the last survey, or the last app, was Survey 123, and that's where I transitioned from the map into that survey form.
Yeah, here's one that's related to that. Oh, I'm sorry. Go ahead.
Yeah, no. Next question's fine.
Sure. Is the mobile ArcGIS application available on different platforms as an Android OS?
Yeah, so Collector and Survey 123 are available in Windows, Android, and iOS.
Okay.
And then Explorer would be available for Android and iOS.
Good. You showed the CDRs in there. Can you handle millions of CDRs?
Yeah, I can take that one. Yeah, so we can. We've got a variety of options to be able to leverage the strategic planning tools and the spatial analysis that we showed, either directly through ArcGIS, or we can take our spatial libraries and bring them into your big data environment. A lot of our users have had Hadoop clusters deployed for quite some time and have been recording those millions and millions, if not billions, of records over time. So we can take our spatial libraries directly to that, generate those results that can then be pushed into the rest of ArcGIS.
Okay, good. What data do you need to run the backhaul planning?
Yeah, I can take that one. So the backhaul planning tool requires kind of three main pieces. The first two typically come from an organization. They are the locations that you want to build out to. So in the example that we showed, it was one wireless site and then 3 building locations. But we've had a lot of users do it strictly for wireless backhaul with hundreds of sites. And then the second is the different access points that you want to backhaul to. Now, if you've got that network management information or facility information in a non-GIS format, you can either just extract those access points, or there's another tool to allow you to create predefined access points at a given distance along a fiber route. So if you've got those fiber routes in GIS, you can add those access points along it. And then the third piece there that is required is a network data set. So part of ArcGIS, we provide a street data set that can be leveraged for that routing. Now, a lot of our users will take that network data set, combine it with their own network information, and create a comprehensive network data set that includes new build areas that leverages the street, as well as uses their existing plant that they can overlash on top of or connect into.
Here's a related question to that. Will we get access to the model used for generating the backhaul?
Yes, so the backhaul model is available through our solutions, and it's something that you can download. So if you have our desktop application, you'll be able to run that tool.
Okay, good. Here's another one related to mobile. Is the tool having the capability of mobile apps with auto update of fiber information while the engineer is in the field?
Right, so I'll take that one. So it depends on how you want to share that information. If you want to dynamically update your fiber designs database and have that be reflected throughout your GIS and on your mobile devices, you can certainly do that.
Okay. Where do you get the 3D building data?
Yeah, another great question. So there's a few options for those out there looking to grab that data. One, you can use building footprints and extrude the buildings if you've got the height value of those buildings. There's a lot of data coming out for building footprint data, and using some of the machine learning tools that are out there, those building footprints are becoming more and more readily available. The other is purchasing the complete building in its 3D form from one of our business partners. So we have quite a few business partners that do provide building data, LiDAR data, clutter data, so all sorts of 3D data, as well as elevation data to be able to do that wireless planning or that line of sight planning.
And we've been getting a number of questions here from different countries regarding their specific needs for 3D data and building data. How do you respond to a particular country's request for that kind of information?
Yep, I can take that one too. So we've got partners that span globally. So while it's going to vary country by country, there are partners that are starting to collect that building information in different local regions. So the best thing, if you are interested in that data, is to reach out to us. We can get you in touch with a local distributor in your area who will have a better idea of the different Esri partners that are offering that type of data in your region.
Okay, good. This one's related to data as well. You showed a lot of different base maps that you could select and look at. Can a local base map service that is not native to the Esri base map, so not loaded in the software there, but located local to a country's mapping agency, be incorporated into the desktop for visualization?
Yep, the answer to that is yes. So Esri provides a set of out-of-the-box base maps that span globally. Now, if you're looking for higher quality aerial imagery in an area and you know that a local agency is providing that, you can grab a map service directly from that agency, or you can build your own base maps using the desktop tool and provide that as a map service through that system of engagement to the rest of your organization. So as users are using the mobile tools or the desktop tools, they can change the base map to one of the Esri standard ones or one of the ones that you have pulled in and created.
You showed a lot of different networks. Can your solution load simultaneous coverage of other telecommunication systems at the same time?
Yeah. So that question comes up quite often. So we've got Esri partners that specialize in the RF design space, but there are a lot of vendors that also have solutions for the RF coverage and RF design. A lot of those formats are a raster format that can be natively read by ArcGIS. So a lot of times we see users that use a different design tool for the propagation, but then just integrate or consume that data, whether it be a certain raster format like a tab file, directly into ArcGIS so they can consume kind of all the coverage data from these other systems in one place, leveraging that kind of system of engagement infrastructure so that they can create kind of a compiled coverage map and then push that out to other members of the organization.
Okay. Here's a question about fiber optimization. when you put in fiber lines, are they optimized, or if the engineer thinks he can do a better job, can he route them?
Yep, another great question. So that tool is intended to be what we call an 80% tool. It has some out-of-the-box design criteria that you can build into it, but you can also extend that model based on your own design criteria. You also have the flexibility of then modifying those routes that were generated. So either through that walkout survey or even through the desktop survey, if an engineer decides, you know what, we actually have more capacity going this route, or we want to go down this segment of street because we know that there is pole availability, they've got that flexibility to go in and manually modify the route.
I might just add one comment to that. To Patrick's point, that model is very configurable, and so you can incorporate other data sets within it. So he also showed some, or referenced some layers coming from our Living Atlas that looks at anything from demographics to physical geography layers like soil corrosion. And if you want to incorporate a cost element to that routing tool that finds not only the shortest distance, but maybe a path that's actually accumulates less cost in the process, you can certainly configure the model to do that. And we've had customers and users do that.
Very good. And we've got a couple questions along this line, and we do get this a lot. Does the app work offline? We have areas that often do not have good cell reception.
Sure, definitely. So the collector map we saw today is designed, as well as Survey 123, are designed to be able to support those offline workflows. So usually you would start, or you would have the app open in a connected environment to download the content into your device, and then from there you can take it offline. But as you're making the changes or collecting new features, those are then stored on your device until you're back on network, where you can sync the changes back up.
Here's another one regarding the mobile. Does the ArcGIS software come with the apps?
Yeah, I can take that one too. So the apps we saw today will be included with a standard ArcGIS Enterprise or ArcGIS Online subscription. But it should be worth noting that there's other applications that sit on top of those technologies that are available, including, we saw Operations Dashboard today that Patrick showed us. We also have something called Web App Builder, where you can design and build your applications without having the right code. And we also have some other premium applications. If you have a need to perform offline routing with turn-by-turn directions, we have a Navigator application designed for that. We also have an Insights for ArcGIS application designed for our data scientists. So there's a variety of apps that are available to you out of the box, and then there's some premium applications you can purchase on top of there.
Okay, great. Here's one regarding the solutions page. Does the solutions page have sample data to get started with?
So I can take that. Our solution site offers freely available and downloadable templates. So these templates are specialized feature function things and tools and maps that help organizations get started. So our backhaul solution actually leverages one of those templates that is available on that solution site. Now, a lot of times those solutions do have sample data to get started, but it really varies template by template, whether or not there is some sample data to play around with and see how the tool or the map or the app actually works.
Okay. Patrick, you talked a little bit about RF propagation. Is there a RF propagation simulation tool?
Yeah, great question. So with the spatial tools that are available in the desktop tool, there's a variety of different spatial analyst and 3D analyst tools that can be configured to do propagation analysis, whether it be based off of line of sight or view shed. Looking at different raster data and elevation models, you can build a tool to be able to do that RF propagation analysis. Now, we do have partners that have also built specific solutions that are directed towards RF planning that leverage our core spatial libraries. So a lot of the times, our users will turn to that COTS solution to do that RF propagation, but using the core technology, you can build a model to do that RF propagation as well.
Here's one for you, I think, Tyler. Is fiber routing as easy an engineer just walks down the path and updates the route?
Sorry, can you repeat the question?
Sure. Is fiber routing as easy as you may look there, sort of as the engineer just walks down the path and you can update the route?
Certainly. So that's one way of approaching it, like we did today, where I could provide markups on top of the existing map, and that's then sent back to the office for the engineers to inspect. You can also configure it so you're actually editing the route. So instead of creating the markups, you're actually moving the route within the collector map. Now, I would advise that you do have a QA, QC process. That way, people in the field are not able to apply their edits directly to the authoritative source. But you certainly got a few different options there. And one point worth iterating here is that these applications we saw today, whether it was collector or even dashboard and the mobile apps, they're all configurable. So if you need to configure and alter the application based off a specific use case you need to support, you can certainly do that using our different applications. And then on that note, it's also worth pointing out that the apps are also designed to work with each other. So if it makes sense to start in collector to view your map, make some changes, but then you need to complete that survey or that verification form, you can go from collector to survey and push that information that you're looking at in collector over the survey to complete your assignment. So you don't have to only choose one application to do the job. If it makes sense to leverage multiple applications, you can certainly do that.
Okay. There's another wireless question here, probably for you, Patrick. Talking about the planning portion, is that the only option for LOS coverage, or is there something that is more advanced propagation models that are frequency specific?
Yeah. So that's kind of touching on where the partner COT solutions come into play. Now, like I mentioned, you can take those core tools and start to add your own specific frequency models into them so that you can build your own propagation tools. But a lot of times our users, again, turn to a COT solution through one of our partners where they have already engineered a solution that has those specific frequency rules built into the spatial analysis tools.
Okay, very good. Here's one, once again, back to the mobile. Can a CSP's existing FTDX network be visually displayed on a mobile app while a new design build is being conducted? So in other words, can you show the existing while you're out there doing the design for a new network?
Yeah, that's a very popular use case to see where you have infrastructure today versus where you're building out to currently and where you're planning to build. So that kind of goes back to how you configure the application. You can certainly incorporate those different phases of your network so you can compare where you have network today and where you expect to have network down the line.
Okay. And there was a lot of different technology shown there. We've got a specific question here about what desktop software was demonstrated.
Yep. So part of that desktop and walkout survey solution, the app that we showed that was the desktop app was ArcGIS Pro. And ArcGIS Pro is kind of our heavy-duty engineer and GIS professional tool to do a lot of that analysis, data management, and then authoring of content into the rest of ArcGIS and pushing out some of those layers so they can be consumed within the mobile applications.
Okay. We're starting to run up on time here. Here's one question. How do you get started with implementing the process?
That's a great question. So we've got a variety of resources that are available to our community. So first I'll highlight some of our ways to stay in touch through the social channels, either through LinkedIn, through our GeoNet community, which is our GIS community of telecommunication professionals, as well as through at Esri Telecom on Twitter. And if you want to reach out to us directly, you can email us at telecominfo@esri.com. You also have the option to reach directly out to your account representative if you have any questions or have additional need to talk further about any of the solutions shown today. You can reach directly out to them or directly out to us. The last thing I'll mention there is we talked a lot about the different geospatial infrastructure, system of record, engagement, and insight, and then the solutions that sit on top of that. Our technology is very modular, allowing organizations to implement it all or one piece. So if you've got design tools, network management pieces, and you're just looking for that mobile piece to kind of complete your workflow, there's an option to be able to deploy that and leverage the data and the investment that you already have. So there's a variety of ways to get started, and engaging with us is one of them.
Yeah, and to Patrick's point, you can start at any level. If you want to start with one use case and deploy what's required for that use case with the intent of growing, we have some really good resources online. One's our conceptual architecture documentation that we update pretty frequently throughout the year, but that gives you just the best practices on how you deploy and design your GIS system. And then we actually have installation tools to help streamline some of the simpler ArcGIS configured environments, or to automate some of the more extensive processes through Chef and whatnot.
That's great. I apologize, we were not able to get to all the questions. There's still quite a few questions here that we'll be getting back to you individually. You showed how to get more information up there, Patrick. We also have our website, www.esri.com/telecom, and be more than happy to respond back to you for any questions that you have. And like I said, we will get back to individuals for the questions that we were not able to answer during the Q&A section here. So with that, I'd like to thank everyone for spending time with us. Patrick and Tyler, I thank you for really enlightening us and showing us the capabilities and the tools that we have out there. And I think fantastic audience just from looking at all the questions that we've got in there. So everybody have a great day.